Hi friends, continuing our discussion on the memory management, let us look at the difference between the logical and the physical address space. The CPU is given with a logical address because we are not sure where exactly the code or the process code is situated in the main memory. Therefore, the easiest way is to talk everything in relative sense, that is from the bottom of the process, just give the index where our current location is situated and all that, and that is what we call it a logical address. So here the CPU will talk with respect to logical address, and then the memory management unit is responsible to convert the logical address into the physical address where exactly we are referring to in the memory. So the address of the memory which we are currently pointing to through this logical address is computed using a relocation register. The relocation register consists of the base address of that particular process. So the base address in this case example, it is 14,000. So to this 14,346 the logical address is added, and then physical address happens to be 14,346. So that is what so instead, if this process gets a place somewhere else which the base address happens to be 220,000, then in this MMU we have the relocation register content equal to 20,000. Then this 20,000 gets added to this, and it becomes 20,346 and so on. So the easiest way to find the physical address is to know the base address of that block, and from there you just add the index, and the index is the logical address we use with the CPU. So CPU works only with the logical address. You don't have to worry much about where exactly it is located in the main memory. It can be anywhere, but yes, one we know is from the base how far the address is which we are working on. So in this case it is 346 bytes away from the base. So base is added to this 346 and we get a real physical address where we want to go in the memory. So that's how the logical and physical address spaces are connected with each other, and that is through the memory management unit and through the contents of relocation registers. So that's about the logical versus physical address space. Next thing is about the dynamic loading. Here the main program is loaded into the memory and is being executed, and all the routines are kept on the disk in a relocatable load format. So only the main program which is required for execution is loaded onto the memory, and other routines are still waiting for their turn in the secondary memory or on the disk in the form of a relocatable load format. Then a routine is not loaded until it is required. So the easiest way of working with any big code using a small memory is don't load all the code at one time. Whatever is required for current situation, only load that one. So mostly the main program will have a smaller size, so we can load the whole main program onto the memory and then start execution. And during execution we may require some routines to be used. It may be a system functions or it may be user defined functions and all that, and till their requirement is there, none of them are took onto the main memory, and they will be put in the secondary memory, and when the routine is required, only then it is loaded onto the main memory. So that way we could solve that uh, problem of using a big process situated in a small block of memory available. And then we have see that dynamic linking and shared libraries. Yes, so we had seen this in our earlier session. The same thing we are going to look at. So here the various object programs, object codes can be dynamically linked as and when required, and we do have some shared libraries that are going to be used whenever we require them. So dynamic linking means loading is postponed until the execution time. So we don't load the part of the code onto the main memory until we are actually executing it. So when we are executing it, then we really understand which uh, component is to be loaded. So we can just load only that particular component which is required for the current situation. So that way we can reduce the memory requirement for every process and unnecessarily wasting our memory, dumping all the code which is going to be used after a very long time, or which is already used and has no more use for the future. So in both the cases it's going to be wastage of the memory. So best way to make sure is load them only when it is required. So this whole thing has to be done at the runtime. So that is what we call dynamic linking. So usually this is used with system libraries. For example, if you're talking about C programming, then we will be using printf, scanf statements like that. And for this printf, scanf statements, we do use the system library. We include a system library that's stdio.h, that is a header file. We include it, but just typing include stdio.h doesn't really load all the functions onto the main memory, because that header file is defining some hundreds of various functions, and this printf and scanf are two of them. So there are many more, and it's even printf scanf is not a function to be executed at every location in your program. So somewhere here and there some scanf statement will be there, somewhere here and there some printf statement will be there. So whenever it is required, only then we can load down the printf code onto the main memory and use it. And once printf work is over, we can just remove that part of the code and allot some other code that particular space. So that's what dynamic linking is. It's usually done with the system libraries. Yeah, so we are talking about the getting in, getting out and all that. So this whole thing is done through a process called swapping, and that is what we are going to see in our next session. So till then, take care, bye.